Alright, boys and girls, this is 1-5, solving equations and inequalities by graphing. And that's the gist. We're solving by graphing, whether it be by hand or technology. Now, a lot of this a junior should be able to do by hand. Some of it's going to be a refresher. Some of it should be established. Every junior I teach, and I say should, it's not necessarily true, should be able to handle mx plus b. But I think if we looked at the seniors who are about to graduate, probably 1 in 4 of them could not. And the juniors are going to be a little worse. But we have a y-intercept at 2, and we rise 3, and we run 1. And we do that for all of time, both in the past and the future. And I'm doing lots of dots because when you're solving by graphing, you hope that the intersection happens at one of those dots. That's what you hope for. Alright, this guy starts at 4, has an understood slope of 1, and there's the intersection. So the intersection happens at x equals 1. You know, not everybody can look at a graph and trace down and see the intersection. I've noticed that. I don't know what happened. And the biggest sin we're doing in education today is we're passing kids who shouldn't be passed. I'm not going to pass you if you don't figure out your stuff. That's a hill I'll die on. I'm not going to pass you if you don't figure out your stuff. You need to figure out your stuff. Alright? I get it. I get that some kids have an issue. You just fall down and look where x is 1. Now, it also says check algebraically. So the algebra on this one's easy, but I've noticed I've got a number of juniors who just can't do it. It blows my mind. We're going to take away x from 3x. I'm going to shift my x's to the left, and if I shift my x's to the left, I shift my numbers to the right, and if I jump equality, I change my sign. And 3x take away x is 2x, and 4 take away 2 is 2. And the next move would be to divide both sides by 2, right? And x is 1, which is exactly what I got. Alright, next one I'll do is 4. 4's got absolute value. You know, you're supposed to remember what mom looks like, but a number of my kids this year do not. That's mom. This one has been shifted right 4 and then down 4. Opposite, trust. Right 4, down 4. Understood 1 in front is your slope. Rise 1, run 1. The slope is unchanged from mama. Lots of dots because you want your 2 answers. I know this one has an answer that's actually off the grid. It's way off the grid. I'm trying to keep my dots about the same, so maybe I'll see it. At least I remember it having an answer last year, and I can't even see my dots now because mine went through them. And then you've got 1/2 x, which again is y equals mx plus b. Remember, there's an understood plus 0. You can always add 0 to anything. Rise 1, run 2. Rise 1, run 2. 1, run 2. 1, run 2. Yeah, I ain't going to catch it. But I know there's an answer over here somewhere. And this is the issue of solving by graphing. There's another answer over here. You know, where is it? I don't know, because I didn't have a grid that was big enough for it. And I'm not going to recreate the problem. I want you to understand that algebra and graphs complement each other quite well. So this solution was when x is 0, and we're going to see that when we solve. I graded a basics quiz earlier. I noticed that a lot of children did not know how to solve absolute value, even though we had a lesson on it. But, you know, it is what it is. First step is to isolate. The absolute value of x minus 4 is 1/2 of x plus 4. Okay, once you've isolated absolute value, you have to write 2 equations. The first one is as is. And on the second one, we change the sign on the stuff inside. The next one I'm going to do is kind of unique. I've done these for a long time, and it's actually the first one that I can remember having to manipulate both sides of an absolute value equation at the same time. There was something I thought was true, and it turns out it wasn't true. Alright, so we're going to take away 1/2 of an x from an x. x, 1 minus 1/2 is 1/2. So we got 1/2 x. We're going to add 4 to the other side. That's going to give us 8. And it turns out this right side here, which was the original equation before I modified it, has an x value of 16. Now, if you're wondering where I got the 16 from, you obviously failed 5th grade math and were promoted. 8 divided by a half is the same as 8 times 2, which is 16. So there's the x value over there. When you negate the equation, you get the left side of the v. That's what happens. Which is probably why, okay, that makes sense. I'm going to shift this guy over here to make it positive. What's a half plus 1? That's 3 halves. So I'm going to have 3 halves x on the right, and the left is going to be 4 minus 4, which is 0. And if you divide 0 by anything other than 0, it turns out that you get 0 back. So that's the one I had. So there's my two solutions, 0 and 16. All right, number 6, and I just realized why I was having a problem with this, okay? And it's something I have actually not established a connection to until today, and I am 44 years old. Let's do our shifting here. This is going to be left 2, down 8. I'm really putting an emphasis on graphing this year, so there's going to be some little things that I will catch that I was never taught. And I have read textbooks that have said you only have to modify one set of absolute value. A textbook written by Pearson, and well, at least published by Pearson's, and it turns out that's not true, and I finally today caught on why. All right, the next guy here, this is left 4 down. Oh, I need to do my slope. Rise 1, run 1. Generally speaking, what we do is we just trust the opinions of others, and maybe I've just forgotten something. Maybe I didn't read something right. But I know that I told y'all that you only had to manipulate one of the absolute value equations to get the answers. And I've also told you not to trust algebra. So there's the one on the, that's that one. I need to graph the other one, which is left 4 down 2, and it has negative slope. So I'm going to fall 1, run 1, fall 1, run 1. Fall 1, run 1, fall 1, run 1. Now, from the graph, I can tell you that x is negative 4, and I can tell you that x is 0. Solving this by hand, I am going to kind of cheat a little bit here. Well, I'll add the 8, because I tell you all to isolate absolute value first, because it's just easier. Negative 2 plus 8 is 6. That equals the absolute value of x plus 2. So something happens funny here when you just change the signs on one thing. And the reason it does it is because of what's going on here. So when you don't change anything, you're dealing with the right side of the V. Notice how I didn't change any of the numbers? This is the right side of the V. Distributive property, negative x minus 4 plus 6 equals x plus 2. And let's see here, what do we have here? We have negative x plus 2 equals x plus 2. Let's shift our x's to the right. That'll give us 2x. Numbers to the left. That'll give us a 0. And x is 0. That was that one. If I want to find the intersection of both left sides of the V, I need to change the signs on both pieces. And that is not something I had taught you because, and I swear I remember this, the textbooks that I've looked at have never said you had to modify both sides. They've always said just play with one of them. Well, if you only play with one of them, you end up with quite a conundrum here. So I'm going to show you what happens if you only play with one of them. So you leave the left-hand side completely alone. You just drop the bars, turn them into parentheses. And you change that right-hand side to negative x minus 2. And what happens is when you shift your x's, this would be negative x plus x. You get no x. This is 2, and negative 2 minus 2 is negative 4. You get this, which makes no sense, right? It's undefined. But since I'm interested in both left pieces, what I actually need to be doing is I need to be changing the sign on both pieces. So I need this. I need to change that to negative x minus 4. And again, maybe Milbrath has forgotten. Maybe Milbrath read something wrong. And I need to change this one to be negative x minus 2. I don't proclaim to be perfect. I'm actually not, my degree is not in mathematics, it's in computer science. Distribute the negative, I get x plus 4 plus 6. And now I'm in business, okay? That'll give me x plus 10 equals negative x minus 2. Let's do a shift left on the x's and a shift right on the numbers. X plus x being twice x, negative 2 minus 10 being negative 12. Didn't add 10. A lot of y'all that I'm teaching this year are making tiny little mistakes. That's killing you. Divide by 2 and you get negative 6. Which is the other answer? Or no? Something's wrong about that. Oh, I was supposed to shift 4 and down 2. I have no idea what I'm doing. This one's supposed to be right here. And then it falls 2 and runs 1. It's supposed to be right there. That's the same. This is me making a mistake. But yes, that's x equals negative 6. So, there you go. Maybe we both learned something. But when you're setting up absolute value, and a handful of you will catch on to this, it's about the sides of the V. All right? Use a graph to solve each inequality and then solve algebraically. How many of these quadratics have I got in here? I got 3 of them. I'm going to leave that one for you. I'll do this one. What we're going to do is we're going to find the vertex. And the x-coordinate of the vertex, and this is something that's so hard for kids to remember, even though it was taught to you in Algebra 1, is that opposite b over twice a. So a is 1, it's in front of x squared. B is negative 7, it's in front of x. And c is negative 8. So opposite of a negative 7 is a positive 7. It's going to be over twice a 1. 7 over 2, we'll use the decimal 3.5, okay? Now, if I want the y-coordinate of the vertex, I have to plug that in. Gonna get a little ugly, right? You know, 3.5 squared minus 7 times 3.5 minus 8. Let's just see what that is. I'm going to use something called the storage feature here. I like the storage feature. Take a 3.5, store it to x. I hit 3.5 st over store x. Original equation was x to the second minus 7x minus 8. And it's at negative 20.5. I remember that. It's been a year since I've done this one, but I remember that. Negative 20.25. Which is not going to be on your grid. Which is not an issue. It really isn't. Because of what this is asking. So back 3.5 units, we fall way down here. Now we need to find the x-intercepts, and we do that by letting y be 0. Now letting y be 0, or setting equal to 0. So let's take our equation, x squared minus 7x minus 8, and let's set it equal to 0. Let's do our favorite F word, which is factoring. Takes an x and an x to create x squared. Factors of 8 are going to be 1 and 8. I need it to be a negative 7 when I add, so negative 8 plus 1 is negative 7. Now I get to use what's called the ZPP. X plus 1 is a 0, or x-intercept, or x minus 8 is a 0. So that tells me that x is negative 1 and x is 8. Pay attention to what happened when I left parentheses. The signs changed. So I have an x-intercept at negative 1 and positive 8. And my vertex is way down here. And here is my graph. Wonderful, huh? And graphs are legit the best way to do a quadratic inequality. Greater than 0 means above the x-axis. It doesn't have equality either. But you're above the x-axis if x is less than negative 1, because you're running left, and x is greater than 8. That's how it works. Now, when it talks about solving algebraically, what you have to do is you have to test on a number line. This is how your college Algebra 140 teacher is going to teach it next year if you take dual enrollment math. They're going to have you do a number line. So you're going to test on a number line. And it's just fun, exciting stuff. Like, it's so much fun. 0 is the most important number. Negative 1 I'm going to put an open dot because I do not have equality. 1, 2, 3, 4, 5, 6, 7, 8. Also an open dot because I do not have equality. And what I have to do is I have to test around these numbers. So like I want to see if something to the left passes or fails. So I'm going to test a -2. So I'm going to go back to my equation. I'm going to plug in a -2. And this is where I usually lose kids because my God, it's so boring. And I'm going to see if it's bigger than 0. That's the question. Well, a -2 that's squared is 4. A negative times a negative is a positive. That's going to be 14. And is that bigger than 0? Yes, it is, because that's 10. So I get to be everything to the left of -1. All right? I have to test in between, so I'm going to test 0 because that's easy to test. I would have 0 squared minus 7 zeros minus 8, and is that bigger than 0? No. So I don't get to keep anything in between. I also have to test to the right of 8. I guess so I'm going to test 9. If I plug in a 9, I'll have 9 squared minus 7 times 9 minus 8. 9 squared is 81. 7 times 9 is 63. I learned that in 4th grade. And that is definitely bigger than that because that's 10. There's also the symmetry aspect of a parabola. Same on the left as it is on the right. So I wasn't surprised that was 10. But that means I get to be everything to the right of that. So here you can kind of see that I'm less than -1 but greater than 9. That's how you test these things algebraically. So like when you do number 9, I will need to see a number line. That's how your college algebra teacher next year wants you to do it. In fact, now your pre-calc teacher, if you take pre-calc, which is me, doesn't like the number line idea. I like graphs. That's why I push graphing really, really hard. Let me say that goes for your instructions on 10. I'm actually going to do number 9. The reason I'm going to do number 9 is because I can make it easier, and it may not occur to you that you can do that. We can divide out the negativity. Now what happens to an inequality symbol if you divide out the negativity is that the inequality symbol flips. So now it's greater than or equal to 0. Now we're supposed to graph and solve algebraically, so we're going to find our vertex. The x-coordinate of the vertex is again at opposite b over twice a. Write that down a couple dozen times till it sticks. B is 2, opposite that's a -2. A is 1, so 2 times 1 is 2, and it's at -1. So this one's better. Like I can do this by hand, right? The y-coordinate of the vertex will therefore be at -1 squared plus twice a -1 minus 15. That's 1 minus 2 minus 15. That's going to be -16. So I got to go to the left one, and I got to fall 16 units, which is probably about right there. And then I need to find my x-intercepts. I do that by setting the equation equal to 0 and knowing how to factor for today anyways. It should factor. Factors at 15 are 5 and 3, and I can get to a 2 with a 5 and 3. So it factors as x plus 5 and x minus 3 because 5 minus 3 is a positive 2. Now hit it with the ZPP, the zero product property. X plus 5 is a 0, or x minus 3 is a 0. If x plus 5 is a 0, the x-intercept's at -5, and if x minus 3 is a 0, the x-intercept's at 3. So one of my x-intercepts is at -5, 0, the other one is at 3, 0. And then I can draw a parabola. Now, when I did the division of the negative, I actually changed the context of the problem. Because I actually changed the direction of the parabola. Originally, the parabola would have opened down. I've changed it around, now it opens up. I want those pieces. Okay? So this is telling me that x is less than or equal to -5. All values of x such that x is less than or equal to -5. And this is telling me that x is greater than or equal to 3. Now, test algebraically. Well, you've done most of the algebra. What you have not done is you have not tested on a number line. So we're going to need us a good old-fashioned number line. We got a 0, we need to be at -5, 1, 2, 3, 4, 5. This one's going to be solid dot because of the symbolism in the inequality. And then at 3, again a solid dot. And we need to test, okay? So I'm going to test a -6. Now I'm going to use my equation, okay? Not that one. I'm going to use this one, the one I modified. I have a -6 squared plus twice a -6 minus 1. That's going to give me 36 minus 12, which is 24, minus 1, which is 23. And is 23 greater than or equal to 0? You betcha. It is. I can accept everything to the left. I'm going to test a 0. So 0 squared plus twice a 0 minus a 1 bigger than or equal to 0. And that is not true because -1 is less than. So I don't get to accept anything in the middle. This is just junk. Doesn't matter. This was where x was 3, so I need to test a 4. So 4 squared plus twice a 4, take away 1, is it greater than or equal to 0? It ought to be, because that's 16 plus 8 minus 1. And again, you got 23. Because you tested things that were equidistant from a root, you got the same result. And the shading goes off to the right, which suggests the same thing we came up with by looking at the original graph. So even, and this is the way it works, when you get past the second degree, when you do it algebraically, you still visualize on a number line, or you look at the graph of the function. All right, finally we're at use technology, and I don't want to do all of these. Like I'm going to do 12, and maybe I'll do 11. I don't know. I guess I'll do 11 and 12. So in y1, I'm going to put x squared minus 8x plus 5. And in y2, I'm going to put x plus 3. And just look at your notes from class. I mean, of course, the downfall is going to be a lot of y'all won't have calculators. Even though you could go to the library and the librarian would be happy to give you one, you're not going to do it because you don't really care if you pass or fail. Zoom 6. And I'm looking for equality here, right? Now, I'm going to have to look up to see this answer. So I go to Window, I go to Ymax, and I'm going to change it from 10 to 20. I feel like that's enough room to see the answer. Let's find out. Only got a few minutes before class starts, so I may not be able to do 2 of them. Second trace, you were supposed to go to 5. Get your cursor close, press enter 3 times. One of them's at 0.2280 if you know how to round. 0.2280, I said 4th decimal, remember? Alright, let's find this one. Second trace 5 again. I'm going to hold my little arrow down until I get close, and when I get close I'm going to release my little arrow and I'm going to press enter once, twice, thrice. 8.7720. Somebody tells you to round to the 4th decimal, you have to leave the 0 there because they said it was significant. Remember that lesson? Alright, I think I will have enough time to do something. Oh, by the way, I set the Ymax to be 20, right? I did. I looked up. Alright, so in y1 you're going to have the absolute value of x plus 2 minus 6. In y2 you're going to have x squared minus 7x minus 2. The only reason I'm bothering to do this one is not because it's difficult, it's because you may not know where the absolute value function is on a TI-84. You had to get math. Scroll to how you feel, and you feel numb, and it's the first one there, ABS. It's not anti-lock brakes. It's absolute value. Make sure you learn how to arrow out. The second one, and don't be that kid who in 3 months still doesn't know where the x squared key is. I see that kid every single year. They sit in my room and they suck up my oxygen. They don't even know how to type in x squared. Blows my mind. Always do a zoom 6. There's your V. You shouldn't be surprised at that V. The next one's going to be a parabola, nor should you be surprised about the parabola. And I don't think you have to adjust to find these intersections. You got two intersections, one here and one there. We find them not by hitting trace, we do second trace. We scroll to 5, we press enter 3 times, and we get one of them, it's 0.2583. And then we repeat the process for the one on the right, second trace 5. Take your cursor, get it close, and press enter once, twice, thrice. Now I'm also going to show this one on Desmos. So 7.7417. Because I know you don't have a TI-84, and I don't mind if you use Desmos at all at home, but you're going to have to make sure you learn how to use a TI-84, because Milbrath is not going to let you pull up your laptop on quiz day. I don't care how locked down they claim they have it. I don't care. Like, I'm a computer science major. I know how to get past all that crap they have. So I don't care. And I did a lot of IT work for many, many years. What do we got here? We got the absolute value of x plus 2 minus 6. Alright. You can actually type that on your keypad. There's a bar right above the enter key. And it was what, plus 2 maybe? I might have read that wrong. It's the absolute value of x plus 2 minus 6. Oops. That was the left-hand side. Right-hand side was x squared minus 7x minus 12. And then you can just click on it. There's one of them. Did I type in the right equation? Minus 2. Okay, here we go. I didn't think those agreed. And am I still right? Absolute value x plus 2 minus 6. Right hand side is x squared minus 7x minus 2. That thing is saying 0.2583. And what did I write down earlier? Okay, same thing. This one over here, 7.7417, which is what I wrote too. So Desmos is an option for you at home, but you better make sure you learn how to use my TI-84. Alright, there you go. There's half your homework, I think. Actually, there's more, isn't there? And I'm out of time. So that's because the bell rings at 11:26, so I'm out of time. That's all the time I got for you. I'm sorry I couldn't do more. Just ran out of time.